Assalamu alaikum. Welcome to today's lecture in Principles of Computer Networks. In this lecture, we will discuss the application layer. We will discuss the DNS, email systems, and WWW World Wide Web. Multimedia and content delivery will be your reading assignments. What is DNS, Domain Name System? Why do we need DNS? What is the DNS namespace? And what are the resource records? What are the name servers? Why do we need DNS? Because it's easier to remember names than to remember numbers. Machines to communicate with each other, they need addresses. Addresses are in numerical form. For human beings, they are difficult to memorize. In contrast, names are easier to memorize. How can we manage this? We can simply have a text file with all hosts, names, and corresponding IP addresses or network addresses, whatever they was. It will work for a small network, but for a larger network, the file size will be a problem, and there will be conflict in host names. Hence, DNS, Domain Name System. Domain Name System is a hierarchical domain-based naming scheme with a distributed database system for the implementation of this. The top-level domains have two flavors: generic, .com, .edu, .gov, .int, .mil, .net, .org, and countries, .cn, .uk, .usa, .sd. The lower-level domains are easy to get. Each domain is named by a path upwards from its unnamed root, such as www.ufk.edu. Domain names can be either absolute or relative. Absolute domain names ends with a dot, like engineering.sun.com, whereas relative paths don't have a dot at the end. A subset of the internet domains are shown in the figure: .int, .com, .edu, .gov, .mil, .org, .net, and for countries .jp, .us, .nil. As you can see here, we have two types of domain names, restricted and not restricted. Restricted like .edu, .government, .military, and not restricted like commercial domain names .com and .net, .org, .business. Each domain, whether it was a single host or a top-level domain, has a set of resource records that describe it. A resource record is 5-tuple: domain name, time to live, class, type, and value. For example, type can be COA, that's the start of authority. These are the parameters for the zone. A, that's the IP address of the host. It's 32-bit integer for IP version 4, quad A for IP version 6, MX for the mail exchange, NS for the name server, and so forth. As we have said, DNS is a hierarchical system. It can be divided into zones. For example, the computer sciences department in Yale University .edu can have its own name server, while Yale can have its own name server. .edu is the domain name of the root domain server. The query for the domain name can be actually carried on in multiple steps, 10 at most. Here, there is the requester sent a query to the local name server asking about the address of a certain name, and the local name server didn't have the address for the certain name, so it has consulted the root name server .edu the root name server returned the IP address of the name server of the University of Washington, where the address is located. The name server in University of Washington returned the address of the name server in the computer science department. The name server of the computer science department returned the name server of the sub-department. That one returned the IP address of the host that is required. The second topic to discuss is the email system. We will discuss the architecture of the services, the user agent, message formats, message transfer, and final delivery. The architecture is very simple. We have the sender with a user agent composes a message and submit this message to the mail transfer agent or the mail server, the email server. The mail transfer agent uses simple mail transfer protocol to send the message to the next mail server. The mail server of the receiver will put the message in the receiver's inbox. Then the message will be sent for the final delivery to the receiver. The basic functions of the email server is basically composition of the message, transfer, that moving a message from originator to recipient, reporting, telling the originator what happened with the message, display emails, dispositioning, what the recipient will do with the message after getting it, to delete it, to put it into a folder, to forward it. Additional functions for email system: forwarding emails, managing mailing list, that's sending an email for multiple recipients, and creating carbon copies for secondary recipients, blind carbon copies for secondary unseen recipients, and to deliver high priority mail and secure mail, to create mailboxes for the user. The message structure resembles the structure of a normal mail message, where there is an envelope and a header, then the message body. There are two message formats, ASCII message formats, defined in RFC 822. That was text-only messages. Then came MIME message formats in RFC 5322 for having multiple formats in a single message, as we shall see. Both defined envelope fields versus message fields. We will here examine the 5322 message fields and envelope fields. The header files related to the message transport, that's to say the envelope, are two. This is the email address or addresses for primary recipient or recipients. Carbon copy, this is the mail addresses for secondary recipients. Blank carbon copy, email addresses for blank carbon copies from the person or the people who created the message. Sender can be a different person than the person who created the message. For example, an assistant sending an email on behalf of her boss. Received, this is a line added by transfer agents. That's to say mail server along the route. Return path can be used to identify the path back to the sender. The message header fields are date, that is the date the message was sent, reply to, the email address to which replies should be sent, and this can be different than the email that the message has been sent from. Message ID is a unique number referencing this message later. Message ID of the messages which this is a reply to, will be in reply to, references other relative messages IDs, keywords, users define keywords, and subject is a short summary for the message in one line written by the user. MIME, or Multiple Internet Mail Extension, was a solution for multiple problems that has faced ASCII message representation. For example, languages with accent, French and German, languages with non-Latin alphabet like Arabic, Hebrew, and Russian, languages without alphabet like Chinese and Japanese, message not containing text at all like audio or images or videos. All this wasn't supported by ASCII, and we needed a new extension to the mail service that supports these file types. MIME has types and subtypes. An example for types and subtypes is text, where there is plain text, HTML, XML, CSS, or images like GIF, JPEG, TIFF, defining pictures, audio, basic, MBG, MB4, defining sounds, and so forth. Simple Mail Transfer Protocol is the protocol responsible for transferring messages between sender, mail transfer agent, and receiver's mail transfer agent. That's to say, email servers. As we can see here, the sending hosts has a permanent connection to the internet. That means a permanent IP address. And the user agent and the mail transfer agent are both on the same machine. The host will compose the message in the same machine and send it to the mail transfer agent to be transferred to the mail transfer agent of the recipient. The next scenario is when the recipient has a dial-up connection with the ISP where his emails are located. This requires another protocol such as POP3 that we are going to discuss shortly to transfer the messages from the server to the user. Simple Mail Transfer Protocol has an extension. The main concern was security. That's why the extensions like authentication and start TLS are both for security, while binary stream, that service accepts binary messages because the oldest type of messages were ASCII, which is different than the binary. ASCII works with 7 bits, while binary works with 8 bits. Junking, that's server accepts large messages in chunks. Size is to limit the size of messages sent. And UATF, Simple Mail Transfer Protocol for internationalized addresses. The final delivery is done by 2 protocols, either IMAP or POP3. POP3, Post Office Protocol version 3, and IMAP 4, Internet Message Access Protocol version 4, were basically defined in RFC 1939 and 2060 respectively. Both uses TCP. POP works on port 1100s and IMAP works on port 143. The emails are stored in the user PC in POP3 and online for IMAP. The users can read their messages offline in POP3 and online in IMAP. The connection time required for POP3 is little because messages are downloaded to the user's PC. For IMAP, the connection time required is much because users read their emails online. POP3 uses minimal server resources, while IMAP uses extensive server resources. POP3 does not allow the user to have multiple mailboxes, while IMAP allows multiple mailboxes, that to say folders. Who is backing up the mailbox? In POP3 is a user, in IMAP the ISP. IMAP is good for mobile users, but POP3 is not good for them because the storage capacity of a mobile device is small. Users have control over the downloading. That's a little in POP3 and great deal in IMAP. Partial message download, POP3 does not allow that, but IMAP allowed it. This quota can be a problem with IMAP, while it's not a problem with POP3 because messages are saved locally. And POP3 is simple to implement, while IMAP is complicated to implement. POP3 has more support than IMAP, despite the fact that now IMAP is more used than POP3, but some people still use POP3. IMAP version 4 commands are examples for them are capability, list of service capabilities, start secure session with TLS, login to log into the server, authentication to log in with other methods, select to select a folder, examine to select a read-only folder, create to create a folder, delete to delete a folder, rename to rename a folder, subscribe, add folder to active set, and unsubscribe to remove the folder from active set. Folders are actually called mailboxes, but for the user they are called folders. Another set of commands is list to list available folders, to list active folders, to give the status of a folder, to add a message to a folder, to get a checkpoint of a folder, to fetch, to get a message from a folder, and so forth. Email final delivery can also be done by property protocols that are used by certain companies like Microsoft Exchange, for an example. Nowadays, the state of the art is webmail like Microsoft Hotmail or Outlook actually, Google Gmail and Yahoo Mail. These are completely online where the mail agents and the user agents are all online. The World Wide Web is our second topic for this lecture. We will go through the architecture of the World Wide Web, what are static and dynamic web pages, the hypertext transfer protocol, mobile web, and web search. The architecture of the World Wide Web is rather simple, where there are web pages with web contents that can be text, images, videos, audios. The web pages are stored in a web server. The web browser is the agent for the user agent that requests a certain web page using the web page URL that we will discuss shortly. To retrieve a page from the web server will respond with sending the page. The web page can contain videos, for example, so the web browser will ask the multimedia server like YouTube, for example, to send the video. The web browser can also connect with Google Analytics, for example, for monitoring the activity in the web page. The web page can have hyperlinks to another web pages. For a browser to fetch a page, it has to know its URL, Universal Resource Locator, and its URN, Universal Resource Name. It's composed of file name, DNS name, and protocol used to access the page. Protocols like HTTP, is used for requesting hypertext web pages. For example, http://www.ee.uwa.edu/robot, or hypertext with security, that's HTTPS or FTP, or if you are looking for a local file, it would be file. And if you are looking for a multimedia call, you will use SIP as a protocol. If you are looking for information about the browser, you will use about. After selecting the URL, the browser determines the URL by seeing what is selected, and the browser asks the DNS for the IP address for the selected URL. The DNS replies with the IP address. The browser makes TCP connection with port 80. That's the HTTP port that's the TCP port. And then it sends a request asking for example, home/index.html. The server will reply sending index.html. The TCP connection will be released. The browser will display the page, and it will fetch and display all the images within that page with other TCP connections. This scenario we have actually discussed can change depending on the hypertext transfer protocol version. The browser can handle many additional types besides HTML. The browser can use MIME types, and this can happen in one of two ways. Either plugins. A plugin is a code module that the browser fetches from a special directory on the disk and installed it only as an extension to itself. So it became a part of the code of the browser. Or helper applications such as Microsoft PowerPoint or Acrobat Reader by Adobe. The web server ability to handle requests has to do with the time it takes to access disks. There are different types of disks: IDE, SCSI, RAID, as you have studied in operating systems. Each one of these has access time different than the other one, and depending on the number of accesses that can be done per second, that will be the limit of the requests a server can execute per second. How to improve the performance of the server? Use caching, as we shall discuss. Make server multi-threaded, where every thread can be executing by itself. Use a server farm for multiprocessors. Use distributed systems, multi-systems simultaneously. Multi-threaded server will have a front end with multi-threads connected to the cache, then to the hard disk. Every thread carries a request instead of a single process that is responding to all requests. The server farm is a number of servers connected to a LAN with a single front end, and each server have multiple threads running on it. That will increase the computational power, and the number of requests can be addressed at the same time. Web is basically stateless, but there are cases where the state of the connection has to be maintained, such as how to distinguish between requests from registered users on a website and everyone else, how to keep track of the contents of a cart for e-commerce, how to customize web portals such as Yahoo for individuals. We can track the users by observing their IP addresses, but that won't work because IP addresses identify the computers, not the user itself, and there can be multiple users for the same computer. On the other hand, many ISPs use NATing that will shield the IP address from the external world. So we can track users using cookies. Cookies can have up to 5 fields: domain, where the cookie comes from; path, the parts of the server that can actually access it, use it; contents, that's a list of name equal value; expire can be non-persistent, no date, or persistent with expiry date; secure, if it returns to a secure server or not. Some examples here are tomscasino.com, path/ contains customer ID, and it has a secure connection. Here, the customer's ID is saved because when the customer returns to the casino, the database can remember the customer preferences, the customer favorite games, what is his habits in gambling. The next one is for a store where the card number is saved, so the customer can go back to his card or her card, know what items are there. The next one is for a portal, and it registers the preferences of the user. The next one is for saving users' ID for future logins. There are two types of web pages, static and dynamic. Static web pages are written in hypertext markup language. Markup language has been around for a long time. First markup languages were for copy editors to send the text files to the printer. Then Terov for Unix, then Text and LaTeX for academia. Last but not least, HTML for web pages. Web pages consist of a body and a header. Each is enclosed by brackets HTML and brackets /HTML. The header is enclosed by brackets head and /head. The body is bracketed by body, brackets body, and brackets /body. The brackets on the slash brackets are called tags, and they can have attributes, and they can be in lowercase or in uppercase, but lowercase is best for compatibility. There are 4 versions of HTML, 4 generations. The first supports hyperlinks, images, and lists. The second supports active maps and images and forms. The third supports equations, toolbars, and tables. The fourth supports accessibility features, object embedding, and scripting. As for dynamic web pages, these are web pages that interact with the user and change its content depending on execution of programs, either on user side or on server side. On server side, there are 2 methods: CGI, Common Gateway Interface, that provide interface to allow web servers to talk to a backend programs and a script that can accept input, for example, from forms, and generate HTML pages in response, or server pages to embed a little script inside HTML pages that have them to be executed by the server itself and to generate the page. An example for CGI is here, where the user fills a form and the form is sent back to the server. The server hands the form to the CGI script. CGI queries the database. The record is found. CGI builds a page. The page is returned, and the page is displayed for the user. Server-side dynamic web pages are generated using multiple technologies: PHP and Hypertext Preprocessor, that pages.php, JSP, Java server pages. This is where the dynamic parts of the page is written in Java programming language. Pages using this technique have the file extension .gsp. ASP.NET Active Server Pages.NET is Microsoft version of PFP and Java server pages, and it uses programs written for Microsoft in Microsoft. Network applications it's a network application framework for generating dynamic contents. Pages with this technique have the extension ASPX. Server-side dynamic web pages has solved the problem of handling input and interaction with database on the server side, but they could not solve the problem of interacting on the client side, such as responding to mouse clicks or having dynamic components on the client side. For this, since HTML 4.0, there are technologies used to provide these interactive web pages, which is known broadly as dynamic HTML. The technologies that are used for creating client-side dynamic web pages are JavaScript, which is a very popular way for making web pages highly interactive. Visual Basic script based on Visual Basic, and it's an alternate for Windows platforms. Java Applets runs on Java virtual machine that makes it suitable for any environment. ActiveX controls, which are programs compiled on x86 machine language and executed on bare hardware from Microsoft on Windows. An example here to distinguish between server-side dynamic web pages and client-side dynamic web pages. In A, there is a PHP module at the server where the request is sent, executed on the server side, connecting the database, and the reply and the web page is generated and sent back to the client. to be browsed through the browser. In the second scenario, here the request is sent to the page. The page has JavaScript code inside the HTML that is being executed locally, and the result of the dynamic page will be displayed for the user. Ajax is a set of technologies that work together to enable web applications that are very bit responsive and powerful as traditional desktop applications. The technologies are HTML and CSS, XML, Extensible Markup Language, DOM, Document Object Model, and any asynchronous way for the programs to send and receive data, JavaScript to bind all these technologies together. Ajax uses extended XML language for specifying structured contents. While HTML mixes contents with format because it's concerned with the presentation of the information, XML allows web contents to be structured for automated processing such as search. There is no defined tags for XML. Each user can define their own tag. To summarize what we have said, here on the server side, we have PHP or ASP or JSP interacting with CGI scripts and to communicate with the database on the server side. The connection between the server side and the browser side has to do with HTML and CSS or XML for mutual execution. On the browser side or the client side, we have Java virtual machines, virtual basic interpreter, HTML, CSS, XML interpreter, JavaScript interpreter, some plugins for multimedia, for example, and helper applications, just as we have said, like PowerPoint or Adobe Reader. This together creates dynamic web pages. See you in the next part.